Hey everybody, how's it going? Happy Friday. I hope that you saw the announcement yesterday on my Google Classroom stream that we will not be following the White Hill bell schedule anymore. So everybody, all classes are going to check in on Tuesday morning, irregardless of what period you have science. So be sure you check in Tuesday and again Wednesday and Thursday and Friday. This does not mean that I will be making more work for the week, just more frequent check-ins. Maybe the lessons will be smaller. Maybe I'll give a lesson that covers multiple days, but you need to check in. I might be adding tips or clarifications along the way. So please check in every day. Most of you have, so keep it up. I'm grading your quizzes. Keep an eye for those. They will be the final grade in quarter 4. Good job. So for today, I'd like you to open up your notebook. We're going to continue from yesterday. And on your next page in your notebook, you could call it day 3, week 2, if you want. Or you could call it sound notes, because that's what you were exploring in yesterday's lesson, or the last lesson. What I'd like you to do, most of you have heard the term sound wave before. What I'd like you to do is pause this video in just a few moments, and I'd like you to write what you think a wave is and provide a drawing of a wave. When you hear the word wave, what does it make you think of? We'll come back to this as we go a little deeper. But for right now, please, at the start of your next page in the notebook, create a little model of what you think a wave is and a little brief description. What is a wave? Pause. Okay. Now that you've drawn the wave, which we'll come back to, many of you yesterday did a model of the YouTube video you saw where a car speaker was shaking a window 10 or 15 feet away. And I asked you to draw a model. Now, one student submitted theirs, and I didn't ask for their permission, so there's no name here. But you might have a model that looks something like this, where you've got a car, a music symbol, some lines, and then a shaking window. So there were 3 questions at the end of your Sound Stations lab as well that you were trying to answer. And that's what I'd like you to add next to your next notebook page. 3 notes. So the first question asked, what is needed to make a noise? And while the vocal cords might throw you for a loop a little bit, it's air running across your vocal cords. But you did notice that when we had a tuning fork, we had to strike it. When we had the ruler out on a counter, you had to strike it. If you had an instrument around the room or whatever it was, you had to strum it. So, the first note of what I would like you to, hopefully you got on your answers to your 3 questions at the end of Sound Stations, is that to produce a sound, an object must be struck or disturbed. My apologies for the bad handwriting. I don't have my normal dry erase pens here. So you must first strike an object, provide a force to it, in order for it to produce a sound. The second question asked, what is sound? So what is sound? Well, I'll just show the whole thing. I can't read upside down. Sound is a type of wave produced by a vibrating object. So it's a type of wave, which we're going to continue to explore, and it's caused by an object that vibrates. So the tuning fork vibrates. The guitar string vibrates. your vocal cords vibrate. And they create a wave in that vibration going back and forth, back and forth. Now, my hand doing this is not making a noise, not one we can hear. But if I go fast enough, it would. So it requires a certain amount of vibrations. And the third question asked you, how does sound travel? Sound can travel through air, through a gas, a liquid, or a solid. These are called mediums, something through which something else travels. So sound can travel through the air, through the water, or through a liquid, or through a solid. So I want to come back to this right here. So the speakers are vibrating very fast. They can send these vibrations through the ground, but they also send them through the air. Those vibrations go and shake the window. Pretty cool. But what are these squiggly lines made out of? I am posting on Google Classroom a website that I'd like you to go look at, and it shows an image, a moving image of what is happening when there is sound moving through a medium. So what I'd like you to do is look at this simulation. I'd like you to draw it stationary, still, obviously your paper doesn't move. I want you to draw it, add three observations that you notice about this visual. And then I'd like you to circle back, and the last question is, does this look like the wave you drew at the beginning of this lesson? Okay, that's it for today. We're going to pick up with this with a nice little challenge on Tuesday morning. Vibrating objects cause sound. Have a good day. Bye-bye.